Hi, this is Jeline from the Honors Tutorial. Our topic for today is about solving quadratic equations by extracting square roots. This is for Mathematics 9. Let us have our example, that is x squared equals 25. And this is how you are going to solve for it. Write solution here. And then copy the given, that is x squared equals 25. As you can see, for x, we have here the exponent 2. So therefore, you have to get the square root of both sides. Write a radical here and write a radical here. And then the square root of x squared is x. Why? Because the index here is 2, and then you have here the exponent, which is 2. For you to be able to get the square root of a variable, you have to divide the exponent and the index. So 2 divided by 2, that's 1. So we have here 1. So that is x raised to 1. But we did not write it. It is because when the exponent is 1 in a variable, we are not writing it usually. It is invisible. Next, copy the equal sign here. Square root of 25. Without having the calculator, how are we going to solve for it? Think of a number that when you square it or raise it to 2, the answer is 25. I will show you some examples. For example, I use 3. Then I square it. 3 raised to 2 is not 3 times 2. That is 3 times 3. Always remember that. 3 times 3 is 9. So therefore, 3 squared is 9 and not 25. Let's try another number. And we have here 4 squared. 4 squared again is not 4 times 2. It's 4 times 4. Why is it 4 times 4? It is because your exponent is telling your base, which is 4, how many times are you going to multiply your base to itself, and that is twice because the exponent is 2. So 4 times 4 is 16. 16 is not 25, so let's continue. So we have here 5 squared. 5 squared is equal to 25. Why? Because it means 5 times 5. So 5 times 5 is 25. So therefore, square root of 25 is 5. We will only get the base. Since we are getting the square root, that is positive and negative 5. And if you're going to look at the left side of the equation, we have x raised to 1. Please write x only and then make 1 an invisible number. So positive, negative 5. So this is the answer. Let us have example 2. For example 2, we have here x squared equals 121. Same process. Please write solution here. I'm asking you to write the word solution here for you not to be confused, which is the given, which is the solution. So copy the given x squared equals 121. And since the exponent is 2, we are going to get the square root of both sides. Square root of x squared, that is x, and then you have to think of a number that when you raise to 2, that is equal to 121. So in this case, that is 11. So we have here positive and negative 11. Why is it 11? Because 11 squared is equal to 11 times 11, and that is equal to 121. And we are just getting the base only. Please do not include the exponent when answering. Again, 11 squared, meaning 11 times 11, not 11 times 2. Because your exponent is telling you how many times are you going to multiply your base to itself. And that's it. Always put positive and negative sign here. Why? Because positive 11 times 11 is 121. Also true for negative 11 times negative 11. That is also positive 121. So therefore, we have here positive and negative sign. So that's it for number 2. Let us have another. For number 3, we have here the square root of x squared equals 50. So this is what you're going to do. Please write the word solution first and then copy the given, that's x squared equals 50. Since you can see here that we have here an exponent which is 2, please get the square root of both sides. X squared, square root of x squared is x. Square root of 50, not a perfect square number. 50 is not a perfect square number, so please look for the factors of 50. One is a perfect square, the other one is not. In this case, we can just use 25 times 2 because 25 times 2 is 50 and also 25 is a perfect square number. So the next thing that you have to do is to get the square root of 25 and that's 5. And then we will not let 2 outside. So that is still inside the radical because 2 is not a perfect square number. So therefore, we cannot get the um, exact value for square root of 2 or a whole number answer for square root of 2. So please write positive and negative 5 square root of 2. So that's for number 3. Let's have another example. We have here x squared equals 72. Same process. As you can see here, please write solution first and then copy the given. So that is x squared equals 72. So you can see here that we have here an exponent 2. So therefore, please get the square root of both sides. And then square root of x squared is x. For 72, 72 is not a perfect square number. So therefore, please get the factors of 72. I know that you are thinking of 9 times 8 because 9 is a perfect square number and 8 is not. But if you are going to use this, you still need to simplify. I will show you for you to understand. So 9 times 8. X equals square root of 9. So that's 3. And then square root of 8. But as you can see here, the square root of 8 is still factorable. So we can still factor it as square root of 4 times 2. So and then let's write it here. X equals 3 times square root of 4, that's 2. So square root of 2 because 2 doesn't have any exact square root, meaning a whole number square root. So we have here x equals 3 times 2, that's 6 square root of 2. So this is what do I mean by you have to simplify again if you are going to use 9 times 8. It is because we can still factor out positive 8 to get the square root. Okay? But I will show you another method if you use, remember the answer is 6 square root of 2. But if you use another number like this, so we have here x squared equals 72. Please get the square root of both sides. So square root of x squared is x. Square root of 72. 72 is not a perfect square number, so please get the factors. So we can have 36 times 2 here. Why? 36 is a perfect square number. So we have here x equals square root of 36, that's 6 square root of 2. So as you can see here, having different factors will result to same answers. But it is your choice to have the greatest perfect square number to factor for you not to simplify again and again and again. So that's for this topic. If you have inquiries about us or about the topic, kindly contact the Honors Tutorials page. I hope that you have learned something today, and God bless.